Hello everyone. We have performed a project titled Electronic Fuse. Electronic fuse are connected in series with the equipment to protect it from high voltages. This is the circuit setup of our project. This is the voltage supply. It will supply voltage of 250 volt and 50 Hz frequency. This is the transformer which will step down the voltage to 15 volt and 50 Hz frequency. This diode connection is actually the bridge rectifier to convert the supply into DC. This capacitor, resistor, and Zener diode branch will smoothen the pulsating DC. The DC supply is fed to this voltage follower so that the rest part of the circuit do not put a loading effect on the DC voltage. This DC voltage is provided at the inverting pin of the comparator and will further act as the threshold level of voltages. The supply passes through this line resistor and reaches to this load. The load is connected in a combination and the load resistance can be varied as per the equipment to check the level. The voltage across the load is appearing at the non-inverting pin of the comparator. The comparator will check this with the threshold voltages and give the output. These two BJT acts as switches and we are actually using them as the propagation as for propagation delay. As we know, at the starting of the circuit, the load takes a high voltages. So this propagation delay of 10 seconds will keep the circuit running for this 10 seconds. The relay will trip as per requirement when the fuse needs to break the circuit to protect the equipment. When the circuit breaks, the resultant current does not reach to the load, rather passes to the ground. We are placing a diode here. You can place a LED here to check whether the fuse is actually tripping the circuit. Now we will simulate the circuit, and in this simulation we will check whether the current is going to the ground without passing through the equipment. In that case, the voltage will appear as 0. Now we will simulate the circuit. This is the simulation plot. The above is the current flowing to the ground, which is actually very small, almost tends to 2 nanoampere. We can consider it as zero current. That means all of the voltage appear across the load. Now, to check whether the fuse actually can trip the circuit, we will reduce the line drop. We have reduced the resistance of the line so that the line drop may reduce. Now we will simulate this new case. Now let's check the simulation plot. So as you can see, the current is fully supplying to the ground after tripping time of 10-second delay, and the voltage across the load initially appears as inrush voltage but gradually becomes zero after that. In this way, the fuse will protect our load. Thank you for staying with us.